Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The stability of carbocations, carbonium ions, increases with increasing substitution at the positively charged carbon due to hyperconjugation and inductive electron donating effects of alkyl groups. Moving on to the next step. Identify the structure of each carbocation. N-butyl cation, primary CH3CH to CH to CH2+, the positive charge is on a primary carbon with 0 alkyl substituents directly on the cationic carbon. Sec-butyl cation, secondary CH3CH to CH+, CH3, the positive charge is on a secondary carbon with 2 alkyl groups stabilizing it. Tert-butyl cation, tertiary, CH3, 3C+, the positive charge is on a tertiary carbon with 3 alkyl groups stabilizing it. Moving on to the next step. Apply the stability order of carbocations. Tertiary, secondary, primary, methyl. The tert-butyl cation has 3 methyl groups donating electron density to the positive carbon via hyperconjugation and inductive effects, making it the most stable among the 3 options. And for the final step, why other options fail? A. Sec-butyl is less stable than tert-butyl because it has only 2 alkyl groups on the cationic carbon. C. N-butyl, primary, is the least stable as the cationic carbon bears no alkyl substituents for stabilization. D. None of these is incorrect because tert-butyl is indeed a valid and most stable option among those listed. Therefore, the correct answer is B. Therefore, the correct answer is option B.